Oh, I didn't know chat was closed. Okay, do y'all want? I'll try this out. I'll have it open to everyone right now. If we can't handle this, then I'll close it. So hopefully we can handle it. All right. It's open to everyone now. So far, it's okay. No one has typed anything. Oh, my bad. Oops. Okay, there. Okay, I think people know you're here, so I don't think we need to say hi. I'm just kidding. All right, let's get started. First off, thank you so much for submitting homework. The homework was a bit long. I put 2 sections in it. One was review sections. One was a review section. One was a mock number sense test. So I didn't really talk about the number sense test, right? Basically, in number sense, usually, okay, please stop typing in the chat. In number sense, there's 80 questions and you have 10 minutes to do it, right? So on average, if you want to go through the whole thing, then that's like 7.5 seconds. The grading works like this. Let's say I start at number 1 and the last question that I finish or attempt is 29. Then any incorrect answer or blank answer before that is going to be minus 4 points, and any correct answer is plus 5. All right. So a funny story was the first time I did it, I read the instructions wrong, so I put an answer in number 80. So I ended up getting every single question before number 80 wrong, except for the ones I got right. It's a big oof. And good question. Yeah, how do you submit homework? Well, you go to kidteachkid.org, and then under classes, there's a tab called Student Homework Submission. Okay, I'm going to close the chat. And then here you have to put your full name, your email, a consistent one, submission for week, whatever, subject, and then attach file. For number sense, I really don't care what type of file it is. And yes, you can submit it at any time. Okay. And then what is homework worth? Well, why do we have homework in the first place? For number sense specifically, homework is really important because we need a lot of practice to get better, right? But we actually have a new point system. So in this announcement, in this email, we sent out new information about the point system that we've put in. You may not have seen it because typically we don't put information inside these emails. But if you scroll down in this email, it was sent out on Friday, then you'll get more information. Okay. So the homework is posted each week after class. Typically, I make mine after, so today around like 7 or 8, just because I don't know how much we'll get through during class. And you'll find everything again inside class resources. Can't exit, right? In the Kid Teach Kid website. So if you go to Kid Teach Kid and then open summer camp class resources, then you'll get class presentations and homework for everything, and the video. All right, so we have a lot to cover today, so I'm just gonna start presenting. And this is the point system. Who are the panelists? I'm the only panelist today for now. Okay. So our agenda today is Simon's favorite factoring trick, but not really, and we abbreviate this as SFFT. Second, we have the modulus operation, and third, divisibility rules. So today is going to be more of a difficulty spike compared to last time, because we're going to go into like actual proofs. Okay, so I called this Simon's favorite factoring trick, but it's not really that because normally, first off, here's the equation: xy plus xb plus ay plus ab equals x plus a times y plus b. This is just using the distributive property. Sorry. And then you might have seen this before because in contest math, we go from the left to right direction, right? We don't usually go from the right to the left because that's pretty straightforward. But in number sense, we'll be plugging in numbers for x, a, y, and b. So we'll be focusing on the right to left direction. Okay, so I'll keep it up for a second. Yes, you get points for late homework submissions, and you get points for attending the whole class. Okay, so this is really similar to something we did last time. So the problem is find 103 times 104. So this should be really quick. And I have the formula in the top right corner. All right, 5, 4, 3, 2, 1. I hope that was enough time. So how we do this is we write 103 as 100 plus 3 and 104 as 100 plus 4. If it weren't these numbers, then you would choose instead of 100 something that's like a nice number, maybe like 50 or 20 or 10. But in this case, both of them are really close to 100. All right, so from here, we get 100 times 100 plus 100 times 3 plus 100 times 4 plus 3 times 4, right? That's using SFFT. So I'll combine 100 times 3 and 100 times 4, so I get 7. So in the end, I get 10712. Right. This is really similar to what we did last time because last time we were only working with perfect squares. And excuse me, but I have to pull up my MS Paint. So last time we did like 103 squared equals 10609. And this number was twice of 3. This number was 3 squared. This time we're generalizing it. So instead of squared, we're doing any two numbers like this multiplied together. So this is 10712. This number is 3 plus 4. This number is 3 times 4. So it's really similar. I'll be talking about the math competition at the end of class. Okay. So this is something new. Now we have a way to do quick multiplication for any type, any two numbers, right? Specifically, we're going to be talking about two-digit numbers multiplied together. And this is something that you should have really, really ingrained into your head. Okay, so how do I do two-digit numbers multiplied together? Well, I'll write the first one as AB, the other one as CD. So I can write AB as 10A plus B, and then CD as 10C plus D, expanding, and then grouping those two terms together, I get 100AC plus 10AB D plus BC plus BD. Yeah, it's similar to cross multiplying. Okay. So let's try this out real quick. I'll give y'all 30 seconds to do it. And try to do this without writing anything down. I forgot the numbers, 31 and 57. Okay. for those of you who just came in, physics has moved to 5 to 6:30 because Roshan wants a lot of time. He wants to talk about, I don't know, like Newton's second law. Yeah, cloud energy. Okay, I think that was 30 seconds. Now, here's something I don't want y'all doing. I actually don't really want y'all to use the formula by like plugging it into, oh shoot. Okay, never mind. I don't want y'all to like plug in directly. So I had those like A, B, C, Ds. But typically, if we're doing this in our head, we don't want to like keep track of, oh, A is 3, B is 1, and etc. So I first start off with 3157. What I like to do is do the middle part first. So the middle part is 10 AD plus BC. But what this really means is I'm multiplying these two, and then adding them together. So that's 21 plus 5, 26. And this is all in my head. And I remember that for each of these, there's a factor of 10 in it. So I have 260 in my head, right? Then I like to do 100 AC. So this digit and this digit, which is 15. So that becomes 1500. And then I like to do the units digits last. So 1 and 7, that's 7. So at this point, I just add all of them. 1500, so 7. That's 1767. All right, yeah, a lot of y'all got that. Yeah, there's a lot of ways to do this actually. I wanted to choose a random example, but maybe maybe you have another way to do this problem, like 30 times 57 plus 57. Yeah, that's a good way. So here's the steps written down. The slides will be on the website, so I'm just gonna speed through this. Okay. And just to note, you don't have to have the same X and Y. Like, I could write this as, I wrote this as 30 plus 1 times 50 plus 7. Right. Okay. Second one, I'll give y'all 15 seconds this time. There's multiple ways to do it. I'll just do it the way I just did it. But if you want to do it a different way, go ahead. Okay, I think that was 15 seconds. Yeah, this is pretty hard to do. I'll do two methods. The first method, which is actually more reasonable for this one, is to do 80 minus 1 times 17. So I get 8 times 17 times 10 minus 17. 8 times 17 is 136. And add a 0 to that, subtract 17, I get 1343. All right, cool. Or I could do method 2, 70 plus 9 times 1 plus 7. 10 plus 7. And in reality, would this be faster? It probably wouldn't, right? So what I want is that in the end, after this class, you'll have a better understanding of when to use certain methods. But I'll just show it for as a demonstration of the formula or like the process. So first I do, I'll actually write it down again. I do outer and inner. So that's 49 plus 9, 58. I have 580 in my head. Then I'll do first and third. So that's 7, so 700. Then I do second and fourth. That's 63. So adding all those together, I get 1343. Now you'll still notice this is kind of slow, right? If I actually instead of doing all this, just wrote out 79 times 17 and multiplied it together, I might even be faster than this method. Okay, so how do I do this fast? Well, to do it fast, you have to do it all in your head, right? So if I'm trying to do this in my head, here's kind of what it looks like in my head. I have 79 times 17, so I store a 58 in my head. And I keep track. I remember that this has a 10 associated with it, but I don't necessarily think and remember it as 580. I just think of it as 58, and then it has a 10 with it. Then I do these two, so 700, and 700 is just 7 with 100, right? Now this has one more factor of 10, so what I'm really doing is adding these two, 58 plus 70, which is 128, then multiplying that by 10. And then now this number you should remember. So you have 1280 in your head now. Finally, you can just look at the units digits. That gives you 63, and then add it to that. So that's 1343. Again, if this is a slow method for you, by all means, don't use it. But if you can get really good with this method, then that'd be really good. All right, any questions so far? I don't think y'all would have questions here. If you have any questions about the process, just let me know in the chat and I'll try answering it. All right, let's try these. Some of them you may not have seen before, like number 2. Some of them you've seen the structure before, like 1, 2, and 3. You've seen that before because we did something really similar to it last time. This time it's more generalized. And then 4 and 5, you can do in any method. Okay, let's do 1 minute. All right, awesome. We had one person do all of them already. Wow. Okay, 10 more seconds. Yeah, I had a lot of different answer formats. If you want to put a number by it, that'd be cool. If you don't want to, that's fine too. If you want to send it all at a time, I guess that'd be easier to read. So I saw a lot of right answers, and thank you for those submissions. We'll start with the first one, and I'll go through really quickly. 102 times 108. We do what we did before. We have a 1 here. Add 2 and 8, we get 10. Multiply 2 and 8, we get 16. Then we have 107 times 96. So this is a bit different, but it's really not too hard, right? We can write this as 100 plus 7 times 100 minus 4. So this is 100 squared, as usual, and then plus 3 times 100. Does it make sense where I found this 3? This was 7 above 100. This is 4 below 100. So I add 7, subtract 4, I get 3. Then finally, I have minus 28. So this is 102.72. Okay, number 3, 50 times 50 plus 7 times 50 plus 10. And that's 2860. And for all of those, I think most people got this right. If it's fine, that's okay. I think with more practice, we can get it down. Number 4, 34 times 12. There's multiple ways to do it. One way you could do it is 34 times 10 plus 34 times 2. So that's 340 plus 68 is 408. If you did it the other way, you would also get the same answer. And then finally, number 5. What? I would probably do 30 times 42 minus 3 times 42. And if you have a different, oh, actually, that's bad. I should do 27 times 40 plus 27 times 2. So that's 1080 plus 54, which is 1134. All right, awesome. Can I explain 3-digit times 3-digit? At that point, it might be better to like just write it all down using a multiplication diagram like that, because there's just way too many things to keep in mind. Okay, so that's enough for multiplication. We're going to move on to the modulus operation. So this is going to be a bit harder because we'll move into proofs. Okay, so first off, a definition. 2 numbers are congruent in mod n if they have the same remainder when divided by n. You can have scratch paper for this. So examples are 6 is congruent to 2 in mod 4, 1 is congruent to 10 in mod 3, and so on. Are there any questions about how mod works or what the definition is? Yeah, it's basically a remainder. So I could say like, oh, like what does the word mean itself? I'm not sure. Well, a modulus class is basically like everything that's congruent is in a certain class. And everything in that class is like you can replace. They're basically like in the same congruence class. That's how you would say it. But I won't go into that. Here, like the first example where it says 6 is congruent to 2. If I took 6, divided it by 4, then I would get 2, right? If I took 2 and I divided it by 4, I would also get 2, a remainder of 2. So both have the same remainder when I divide by 4. Same with this one. 1 divided by 3 has a remainder of 1. 10 divided by 3 has a remainder of 1, so they're congruent. This one, 10 2 times 5 is 10. 2 times 16 is 32. Both have a remainder of 10 when I divide by 11. And the last one, 12 plus 8 is 20. If I divide that by 5, I get a remainder of 0. And if I divide 0 by 0, I also get a remainder of 0. Does that make more sense? And yeah, if this doesn't make sense to you, just think of this symbol as equals. Okay. So we say x is congruent to y mod n, but it's the same thing as saying x equals y plus k times n, where k is some integer. So this example here is 13 is congruent to 1 in mod 3. It's the same thing as saying 13 equals 1 plus some integer times 3. Right? So 13 equals 1 plus something times 3. And this something was 4 in this case. So what about like 15 and 37 mod 3? Well, is 15 equal to 37 plus something times 3? And if it is this a number in integer? If it is an integer, then those two are congruent in mod 3. Otherwise, they're not congruent. All right, no, because if I move this 37 over, I get negative 22 equals something times 3. And there's no integer that would go here that could satisfy this equation. So this basically means that 15 is not congruent to 37 mod 3. This 3 is that 3. 15 is that 15. This 37 is that 37. Does that make sense? Are there any questions? It may be more difficult from here. Okay. So first, notice that 13, because 13 is congruent to 1 in mod 3, 13 squared is actually also congruent to 1 squared. So I had, and I'm going to leave out the mod. Oops. So I had 13 is congruent to 1. This implies that 13 squared is congruent to 1 squared. Now, is this always true? Do y'all think this is always true? If I have like a is congruent to b, is a squared always congruent to b squared? Oh, I actually have a lot of yeses, a lot of nos. Wow, okay. Well, let's see. Oh, and just a clarification, this is all in mod 3. Mod 3. Is 169 congruent to 1? Yes. Okay, so let's just choose some mod n. Let's say it's in mod n. So this is what we're going to prove. Or disprove. If a is congruent to b mod n, is it true that a squared is congruent to b squared mod n? So this is the question. I kind of gave it away in that text box, but let's see if y'all can figure it out. And if you want to take a break here because you don't know how to write proofs, that's totally fine. Just come back in 2 minutes. I still see a very even split. Okay, if you just came and you weren't here in the beginning, I'll be talking about like all the new updates at the end of class. To start off, number sense was moved to 4 to 5, and then physics is 5 to 6:30. Okay, I'll give y'all 1 more minute to write a proof. Okay. Do y'all need more time? I'll just get into it because we actually have a lot more to go through. All right, so if x is congruent to y mod n, then x squared is congruent to y squared. I'll actually prove this is true. So surprisingly, this statement is true. Okay, so we're assuming proof. We know that x is congruent to y mod n, right? And this is given. So what does this mean? Well, from the definition of mod, x equals y plus kn, where k is some integer. This means k is an integer. So far, does this make sense? I'm just using the definition of mod, because if x is congruent to y mod n, then I can write x as y plus a certain number of n's. Okay. Now my end result is supposed to be x squared is congruent to y squared, so I'm just going to square both sides to get that squared term. Oh my god, my stylus is bad, guys. And my computer. Okay. So expanding, I get x squared equals y squared plus, and I'll use the formula we talked about last time, plus kn squared. All right. Okay. Now I have something similar to what I want. Sorry, give me 1 second. Okay. I have something similar to what I want, because in the end, if I'm trying to prove x squared is congruent to y squared, then this is the same thing as saying x squared equals y squared plus n times some integer like j, right? So this is kind of what my end result should be. This is where I want to head with my proof. Okay, so now I have x squared equals y squared plus this. And what I want to do is factor out the n. So I'll leave the x squared and y squared as they are. But I'll factor out an n. So I'll write all the terms without the n. So I just took out an n from these two terms. And now I'm left with this mess inside. It doesn't actually matter what this is. Now, why does this imply that x squared is congruent to y squared, mod n? Does anyone know why this implies x squared is congruent to y squared? Right. Yeah. This thing, I can think of it as my j from up here. And I know this is an integer because y is an integer, k is an integer, k is, n is. So this entire product plus sum is an integer. So my end result is x squared is congruent to y squared mod n. Are there any questions about how I did this? And sorry for the bad handwriting. Yeah, we'll be doing examples. Okay, so here's the proof if you want to look at it later. Okay. And then before we do examples, we can actually extend this proof to perfect powers. So for any perfect power, that statement was true. So in general, if x is congruent to y mod n, then x to the a is congruent to y to the a mod n. I had a question, like, why does the fact that this term, just because this is an integer, means that they're congruent? Well, I can go from the definition back to like the original. I can use the definition in both ways. So if this is true, then it satisfies the definition for x squared is congruent to y squared mod n. Okay, so this is something you should keep in mind. And another question was, can you use fractional mods? Yes, but we won't be talking about that because they're not really useful in number sense. Okay. So when do we use mods? And this is still before examples. We won't actually see this symbol much, like the congruent symbol, in actual number sense tests, like the one I gave on the homework. But you will see these properties used to prove certain identities, such as divisibility rules. So we'll be going through all of those. Okay, and how do we use it? Here's an example. Typically, we use it if the problem asks about the remainder. And a lot of you said, yes, the remainder is basically the mod. Okay, so I'll give y'all a minute to do this. Try to write this in terms of mods. Oh, and don't forget that remainder is positive. Okay. Oh, I was holding a pen, not a stylus. Okay, so find the remainder when 146 to the 17th is divided by 7. So this is another way of saying, what is 147 to the 17th congruent to in mod 7? Y'all see how I went from the question to this statement? Oh, oops, yeah. Thanks. Okay. Are you serious? All right, this is really sad. My PC ran into a problem and it needs to restart. So I'm gonna stop this share. Wow, that's actually really sad. Okay. I guess I can't do the whiteboard. I'll try doing the whiteboard, but it's gonna be pretty bad. Okay. Do y'all see this? Okay. So sorry about that. Okay. So the question was, what is this when divided by 7? I'll just explain it. First, we consider in mod 7. So we first realized that this is talking about a certain power of 146. So it'd be nice to use this equation. All right. Well, we know that 146 is congruent to -1 in mod 7. If we took 146 divided it by 7, I would get 6. But normally I want to treat it as -1 because -1 is easier to work with if I'm taking it to a power. Okay, so now I have, do y'all see my mouse too? Okay, so now going from here, I can take both sides to the 17th power. So 146 to the 17th is congruent to -1 to the 17th, which is -1, which is 6 in mod 7. And 6 would be the answer because that's a positive number from 0 to 6. All right, any questions? Okay. Would y'all mind using the chat? Because my Q&A is somewhere awkward. Okay, for equations in mod n, we can replace numbers that are that they're congruent to just anytime we want. So here's a problem. In mod 7, expand and simplify 8x plus 6 squared. And while you're doing this, let me pull it up. If you're looking for a way to like type this in, you can just like use x and just put it in polynomial form. All right, so here's a hint. Is it better to expand then simplify or simplify then expand? And would both give you the same answer? So you can type in your answer to the first question and the second question. Okay, awesome. It's working now. Yes. It is easier to simplify than expand actually. And both are allowed. So let me share my screen. Here. This is so much better. So yeah, as I said, in mod 7, in any mod, you can replace numbers with what they are congruent to. So in this case, what should I replace 8 with? Well, the best choice is, of course, 1, right? So 8x plus 6 squared is congruent to 1x. And then what about 6? Yeah, -1 squared. So this is congruent to x minus 1 squared, which is x squared minus 2x plus 1. And then all of this is in mod 7. Okay, any questions? Okay. So yeah. All right, let's try solving these out. I'll give y'all a minute to do this. So it's just asking for the remainders. You'll be using a combination of tricks that we've discussed. Okay, great. Number 1 is what is 1002 divided times 34 mod 7. And last time I talked about that trick where 1002, where 1001 is 7 times 11 times 13. All right, so this whole thing is just becomes 1, right? I can write it as 1001 plus 1, and 1001 is congruent to 0. So that's 1 times 34. And then you may have noticed 34 is 1 less than a multiple of 7. So that's like 1 times -1. So -1, which is 6. Okay. For number 2, why? There. I have 2 to the 210 divided by 13, so mod 15. Now, what's the best way to do this? Right, you should get a quantum calculator. So we know that 2 to the 4th actually is 16, and that's 1 more than mod 15. Whenever we can, we want to convert numbers inside mods to ones, zeros, and -1s. Okay, so if I have 2 to the 4th here, what exponent do I put up top? Yeah, 52. So it would be 2 to the 4th to the power, whole thing to the power of 52. And then I have an extra 2 squared. So I'll just put that to the side. Now what can I do? This is 16 to the 52 times 2 squared, which is 4. So I can just replace 16 with 1 because it's congruent to 1 in mod 15. All right, so I end up with 1 to the 52 times 4, which is just 4. And I think a lot of y'all have seen this before, so it wasn't too hard. The last one is also pretty similar. 13 to the 9 times 5 mod 3. 13 is congruent to 1 mod 9. Right, because if I divide it by 3, I get a remainder of 1. So this is congruent to 5, which is congruent to 2 mod 3. And I actually just realized that I messed up in the answers here. I'll fix it afterwards. I put 6, 4, and 5. It's a big oof. Okay. So why is this useful? We finally got to it, divisibility rules. So our goal is to know the divisibility rules for 2 through 11. The one for 7 is pretty bad, so you don't have to use it. But the importance in number sense is that these are good for checking your work. So like if I know that my original expression was some number times another number, and the first number had a factor of, in this case, 9, then the product has to have a factor of 9 as well. So I would just test really quickly, does my answer have a factor of 9? If so, then I did it right. And then, of course, it's useful for its most natural purpose, making prime factorization easier. So we'll be talking more about it and more about like prime factorizations later. But for now, we'll just talk about the rules for 2, 4, and 8. So if y'all want to type it into the chat, what the rules for 2, 4, and 8 are, that'd be great. Yeah. Okay, I couldn't read all of them, but they look good. For 2, I'm actually going to use mods for this to be really formal. If I have a number, let's write it in its digit representation. So it has a lot of digits before. Let's say the last 3 are C, B, and A. So this is my number. I don't really care about what the digits are before. So I can write this actually as a bunch of 10 to the power of something times whatever digit it is, right? That's what like base 10 is. So for the last three digits, I have 100C plus 10B plus A. Right, and then if I try doing the divisibility rules for 2, 4, and 8, I'll see that this, let's say in mod 2 first, in mod 2, all of these become 0. So all I worry about is A. So last digit is divisible by 2, or in other words, it's even. If I'm in mod 4, then this thing and everything before it becomes 0. This thing becomes, well, typically we just leave it like that. So if the last 2 digits are divisible by 4. And then for 8, it's just last 3 digits. And I'm sure you'll have more practice with it in the homework. Okay, next ones, 3, 9, and 6. Let's see if we can finish before class ends. For 3, 9, and 6, let's type it in real quick. Yeah, for 3, it's that the sum of the digits is divisible by 3. So this time I'll be looking at mod 3 And if I look at this expression, this equals 1 times whatever digit plus 1 times whatever digit, because all of these are actually congruent to 1 mod 3. All powers of 10 are congruent to 1 mod 3. So it ends up being the sum of all the digits. Sorry. Okay, for 9, it's very similar because all powers of 10 are congruent to 1 mod 9, so I can do the same thing. And then 6, yes, I added it here because there's really no place to put it. It's if it's divisible by 2 and 3. All right, good job. Finally, let's do the next slide. 5 and 10 is way too easy. For 11, I don't know why I keep deleting it. This time instead, it's very similar to 9, but this time actually alternating powers of 10 are congruent to either 1 or -1. So 10 squared is congruent to 1 mod 11. 10 to the first is congruent to -1 mod 11. 10 to the 0 is congruent to 1. So alternating is going to be 1, -1, 1, -1, and so on. So if I add the alternating sum of the digits, then I'll get whatever it is mod 11. Okay, and then finally, for 7, I'll do it really quickly. For 7, it's actually kind of tricky, but all right, let's still do it. I'll write my number x as 10a plus b. Okay, so what is this a? A is whatever's before the last digit, and then b is that last digit. Okay, and then this in mod 7 is actually congruent to, actually I'll work backwards. So if this is congruent to that in mod 7, then 0 is congruent to 5 times this number. I won't really explain why this is reversible. But if I simplified that, I get 0 is congruent to 50a plus 5b. And we know that 50 is 1 mod 7. So that simplifies to a. 5b, 5 is the same as -2, so I can write that as -2b. And all of this is mod 7. So basically what I'm doing is I take everything before the last digit, subtract twice of the last digit, and I get, if that's a multiple of 7, then I know that the original number was a multiple of 7. And I can keep doing the process. Okay, so I'll end it here. We didn't get time to do this question, but that's okay. Just a quick update. If you weren't here at the beginning of class, or if you just zoned out or something, I'll just do this before physics starts. Homework submission is on the Kid Teach Kid website at classes, then student homework submission. And then you get all the homework resources and class resources in summer camp class resources. And we have a new point system if you didn't know. You'll find everything in this email that you may have missed because it was just a Zoom email, but you really want to check it out because we have more updates. And one of those updates is the math competition. Okay, so if you go to this link, you get all the information about the point system and then some information about the tournament. Anyways, I'll leave it here. Sorry for taking so long, Rochen. Let me make you host.